Hello again. This week we're doing Module 2, and so I'm just going to start by talking about the Nature of Science article that we discussed, and actually I'll pull it up down here. I actually really liked this article. I thought it was interesting. I always like to see other people's points of views and kind of relate them to mine, so I definitely agree with your point of view in this article. I did find that I fall into a couple of these misconceptions, so it was kind of refreshing to see your point of view on them, and I can kind of now understand it from a different perspective, which is nice. Let's see, like the first one I fell into for sure was, I kind of always thought, I've always been taught, even starting in elementary school, you learn about the scientific process and all these things, and as you go through different various science classes, you kind of fall into this idea that that science follows this like chronological order, like the hypothesis and then a theory and then a law, and as you kind of explain in this, that it doesn't really necessarily follow that. And I definitely I agree with you now that I see this point of view. I have always just believed that you start with the hypothesis, that's what gives you your starting point, and then you do all this background research, and then you now have this theory, and then it turns into a law, which is one way to look at it. But like as you mentioned, which I really like the way you put this, it makes it really easy to understand. Laws are a result of observations. That's what happens. So it's just it's purely descriptive. And so it's kind of like Newton's laws. Those are supposed to be very descriptive of just what's happening. It doesn't explain at all why it happens. Like every action has an equal and opposite reaction, or objects at rest will remain at rest. Those are just descriptions. They're not telling you why that's happening. Now down here you talk about a theory, and the theory is what explains the why. And so I thought that was kind of interesting. I never really looked at it. I never made those like distinctions, so I'm definitely probably going to be seeing that now in my future science classes that I take. Also, the misconception that science is based on facts and proof. We always hear like people say that they believe in science, but if it's backed up by science, then they'll believe it because it's all factual and it's proven. And you kind of challenge that idea in this, which I agree with you. I also do not agree that it's based solely on facts and proof, because you can't use the term fact. And I was a kinesiology major at ASU, and a lot of the classes that we had to take were research-based classes. We had to read a lot of research articles and analyze a lot of articles, and then write several research papers. And one of the things that they really tried to drill into our brains is that you cannot use the word proven. We read a lot of articles that talk about different exercise interventions, and and then when you're doing your results and you show your data, you're not supposed to say, okay, according to the results, according to the data, our hypothesis was proven. Rather, you're supposed to say, evidence suggests, or that there was a significant the evidence was significant enough to suggest that this was plausible, basically. Which I agree with that. I think it's kind of funny that people always say like they believe in science because it's factual and it's proven, when really, like you said, it's not proved. You can't prove it, you can only disprove it. And it's kind of like you're innocent until proven guilty. It's kind of the same thing, like you can only disprove it. So I thought that was kind of an interesting connection, and that was a different way of looking at it. But I agree with that point of view, that it's not all it's not just facts and proof. And especially with technology, the advances in technology and just the different things that they're discovering, I feel like that's really going to open a door for science, and science is going to continuously change because of these new resources that they have that are going to provide more opportunities for more discovery, and therefore they're going to start things that were supposedly proven, they're going to start disproving because they now have the resources to do so. So that kind of just goes to show you that science is not concrete and that it's constantly changing. So I really liked this article. I thought it was interesting, and I learned a lot of things and saw a few things from a different point of view, and kind of confirmed a few other things that I have previously learned, so that was nice. Let's move on to the next 3 questions I responded to last week. The neat resource this week was really interesting. I liked this. I saw a lot of really cool projects. I actually wouldn't mind trying a few of these. Like, I think this one's really cool. Put it somewhere. Or this one, the Easy Share, the Facebook, what was it called exactly? It was called the Face Booth. I think this one is really cool, especially for these days. Everyone's into the whole social media and being able to share your photos like that. This dance floor is really cool. I also went on this Instructables website. It looks like a lot of other people did. And the one I found really kind of relates to me and my life and my personal interests. Where is it? Oh, here it is. Okay, I found this jacket, and basically it's a turn signal jacket, as you can clearly see, and it's for when you're bike riding, which I really enjoy bike riding. I go out all the time, and you know, a lot of times I'll go out at night, and it would be nice to have something like this. I always thought, like, why don't bikes have turn signals or something, some kind of lights on them, because, you know, a lot of times, first of all, cars can't even see you, and second of all, you both come to a stop, and you're trying to figure out who's going which way. And so I thought this was kind of cool, and it kind of relates to my life and my personal interests and things I like to do, so I thought this one would be fun to kind of try and make, and it doesn't look too incredibly challenging, which is kind of right up my alley. I'm not really tech savvy, like I mentioned, so this one looks like it could actually be functional and useful, plus, you know, it kind of relates to my life personally and the things that I enjoy doing, so I thought this one was cool. I saw a lot of other ones that were really cool. I just think that this one is the most functional, because there was one that I thought was really funny. It was a pair of shoes, and they tie themselves, which, that's nice and all, but honestly, I mean, I don't know that that's that useful. I think most people would probably just tie their own shoes, so this is the one I chose. And then the static electricity, I read through the lessons on this page, and then I did a screencast of each of these, so I'll go ahead and show you the videos that I made. The first one, the Jantra voltage. Let's see. Alrighty. So, actually, let's just go back to the regular. Okay, so this one was cool because it kind of showed how the charges come, you know, how the charges enter and how they exit. So, let's start this. He's moving, and you can see the negative charges are entering into his body, and as he touches the handle, which would obviously be positively charged, they all exit. I'm assuming it's positively charged because of the way they exit, because the opposites attract. So that was the first one. The balloons and static electricity. I know I could kind of relate to this one, and this was a neat depiction of how this one works. I know as a kid, me and my brother, we would always take balloons and we'd rub them up against our clothes or our hair, and then we'd use them, do the static electricity thing, make our hair stand up and all that stuff. So this one was kind of a neat depiction of that, and you could see how the ions move from one source to the next. So here you can see the balloon, the charges are balanced, so they're not attracting one way or the other, but when they move over here, the balloon collects the negative ions from the sweater. Now the sweater's positively charged, and the balloon is attracted to the positively charged sweater because these are more negatively charged. And over here you can see that they're repelling each other, the negative charges, and you can see that it keeps attracting to the sweater. And the ones that are balanced still attract both ways. So I thought that was a good depiction of that one. Let's see, the field hockey. I was kind of confused on how to use the bars for the field hockey and how to make it work, really. I played around with it a little bit and I really couldn't figure it out, but I got the overall concept of this one. You have the puck, which is positively charged, and again, it just kind of shows how the positive charges are going to repel each other, which is ultimately what's going to shoot the puck into the goal. And then you have the negative ions, which are the negative ions, which is going to be attracted to the puck, so the puck's not going to repel away, they're just going to kind of bounce back and forth. So you can kind of see that here. Here's the plate. Here's the negative one, and these ones are going to be attracted to each other, so it's not going to shoot into the goal. You see how it just goes back and forth. And then if you take the positive one and move it, this is what's going to propel the puck into the goal, because the ions are going to repel each other, the two positive charged ones. And there's a goal. So that's what I did for this week. I feel like I really learned a lot, especially the neat resources. Let's go back to that. I learned a lot about the kit and starting to learn more about the different projects you can do. And this class is finally starting to kind of come together, and I'm starting to understand what it is, you know, we're going to be learning and all that stuff this semester. So I'm really excited to start this next week playing around with this kit that we just got. This week I spent about 4 hours or so on the course. I spent a little bit less time this week just because I had already done my responses for the 3 questions from last week. I thought we were supposed to do them already, so I was a little bit ahead on that one. So this module didn't take me as long this week, but I really learned a lot and enjoyed it. I enjoy seeing all the things that other people have posted and just kind of getting their points of views on things, and I also enjoy reading your points of view, especially on the nature of science articles. So that's it for this week.